Hello, everyone. Thank you for coming to my presentation. I appreciate you missing part of lunch for this. Hopefully, I can make this worth your while. And that's kind of the through line through my presentation, making AI worth our while and where it is not. I'm James McPherson. I am the gaming data warehouse architect for Churchill Downs. Now, when most people, whoops, sorry, got ahead of myself. So I'm going to be discussing what generative AI wagers made sense for us, how we picked which projects we went through, how they generally went, which ones won and had a positive return on investment, and which ones did not have a positive return on investment even when they worked. And then what you can learn from that and how to benefit from that in the future, hopefully. And if I've done it right, there will give me some time left for you all to ask questions to clarify whatever I've left unclear. So to start with, you have to know what you're going to bet. So you bet what you know. You need to know your business. I work at Churchill Downs. Most people think of our historic paddock, the Twin Spires. But Churchill Downs is an old company. We opened in 1875. But we're not just one racetrack. We are 7 racetracks. We're an online wagering platform. We have multiple back-end services that support both racetracks and gaming facilities. And then we have dozens of our own gaming properties of our own that are Type 1 casinos and historic racing machine casinos. What that means is we have up to 150 years of data, which for some AI purposes is fantastic, but it comes with 150 years of technological change. We started in the age of steam with printing presses. Our data has evolved from that to rented time on mainframes, mini computers, microcomputers, servers, clusters, virtualizations, and in part the cloud. We have multiple kinds of customers. We have our gaming public, who is itself segmented between the horse racing on-prem, online, our different kinds of gaming property customers. We serve other horse tracks. We serve other gaming properties. We have a lot of markets in every way you can define it, and a lot of regulatory environments, which means our business is in a lot of different states. So when I think of Churchill Downs, I think of that. Those are all the different business lines we've got to deal with. So how are we going to pick what we're going to run? Well, we're going to explain it like I'm 5 and start from basics. The who, what, when, where, why. Who is going to be the users, right? What's the LLM going to do for them? What's their user benefit? Where will they interact with the LLM? You don't want to make them go somewhere else. It needs to be where they already live. When will they use it? This seems to get forgotten, but it turns out that's very important for ROI. And why do we want to build it? That one we can answer. We expect a return on investment. We're going to put effort into development. We expect some kind of gain. So our pick 4, we chose marketing, which is admittedly the gimme, our patrons, our developers, and our analysts. So let's look at them. Marketing. Again, low-hanging fruit of Gen AI. It writes texts, it summarizes information. We have a lot of that going back a century and a half. It updates daily. So we use RAG to update the LLM. And we can get a 13% reduction in effort, which for the people who are really good at math, means that that's 1 hour per day for our marketing team. But it also eliminated a third-party service, which is about 1 FTE. So we see this kind of savings. Hooray, confetti party. This is what we expect from Gen AI and marketing. Let's move to a harder topic. Our racing patrons. If you're not familiar with racing, there is a lot of information. This is a standard racing form. It is chock full of data, right? Our racing patrons also have expert picks. We provide these. They can get all kinds of notes. Video channels, we have those too. There is a lot of data. Most patrons show up at the track who are going to be, planned betting, are going to have a pretty solid plan on what they're going to do. But sometimes the unexpected happens. A horse comes up lame. You expected the track to be muddy because of a storm, and the storm just doesn't rain. We expect a dry track, and it's rainy. You need to change your bets. You want to phone a friend. So what if we take what we learned building our marketing LLM that recaps recent events, and we extend it to providing a tool that provides guidance on upcoming events, right? Now, there are differences. Employees review what comes out of the marketing LLM and can detect hallucinations. And it does hallucinate. Every so often, it thinks when a track closes for a storm, it's a hurricane, because we've seen a lot of that data in the training. We have to eliminate that because patrons have a lower tolerance. Had to build a lot more guardrails, had to build a lot more constraints, a little more lather, rinse, repeat for development, but we have a private beta going on with a select group of patrons, and based on our current return on investment, cost of compute, this looks like it's going to have a positive ROI when it goes public. Hooray, more confetti. All right, so let's keep going. Developers. Now, we have, I'm going to say Copilot a lot. Each of our developers seems to have a preference for different copilots, and it seems to vary both with time of year as they get updated and what specific tasks the developers are doing. So I'm just going to say generically Copilot and fill in your favorite. So Gen AI is really good at tooling. So we use a lot of lambdas in some lines of our business, and Copilot builds 95% of those. We do a lot of Python, the testing, also another good Gen AI function. Most of those are authored by Copilot. You get into documentation, and Copilot's producing the first draft of our documentation for the Pythons and the lambdas. It helps with our GitHub. It does a good job of doing an immediate code review and pull request, provides summaries, cuts down some of the developer effort and pain. And we see pretty good reductions in time for those efforts. And some of you are probably wondering, but where's the DBT part of this, right? We don't actually use Gen AI for generating our DBT models, but we did try. And why did this not necessarily work? Well, it goes back to our business. I'm in the gaming side, right, the casino side. Each of those dozens of properties are essentially standalone facilities. The power goes out on the strip here. Those gaming floors are still operational. They're fully redundant, autonomous systems, which means that if I want to pull one table, I'm pulling a table from all those systems, and I have to integrate them together. In DBT land, it looks like this, right? You see dozens of our base models. But when you have dozens of casinos or our horse racing facilities in different states with different regulators, with different allowed games and components, they are never running the same version. So you'll see another layer that groups them according to version of installed software and normalizes that information. Then there's another stage that deals with transforming them to look like the other parts. And then you get to our outputs where we add some extra logic to deal with whether we're showing current data or deleted data, slowly changing dimensions. In DBT terms, this is symmetrical. This is one of our sources. This is what my staging layer looks like. We are very symmetrical. I have 4,000 staging models. There is no intermediate objects here. There's no business logic here. This is just getting the data prepped. And this isn't even all of it. I couldn't fit them all on here, right? And this is from a couple of months ago. It's bigger now. So when we tried LLMs earlier in the year, we used an agentic copilot. The one we used has now been replaced with a newer, faster, better one, but the numbers will stand out here in a second. It could produce a couple of hundred models in 10 minutes, which sounds pretty good. I need thousands. If I do a software upgrade, I might need 2,000 models upgraded, right? The agent would fail to complete and sometimes lie about it. Do not like that. Copilots are creative. They're generative AI. We want them to create things. But they sometimes invent tags. They're not even bad tags. They're very good tags. They're tags that my developers might use later. But now these things are injected into jobs that no one knows is going to happen. That's a problem too. And then the code is inconsistent. Doesn't mean it doesn't run. But remember that pattern. All of those models are basically supposed to look alike except for very minor differences to delineate what source they come from. Variations increase my work. I do the pull requests. I routinely see pull requests with 300 models in them. If they are not normalized, streamlined, organized, my day is ruined. So, version control problems for us. Now, this is something you have to keep in mind with Gen AI. High volume tasks turn possibilities into near certainties, right? A 99% accuracy rate with 2,000 models means there's 20 Gen AI originated defects, as far as I'm concerned, because they're inconsistent. So, what genie do I use? We don't have a genie, we have an agent, or we have a framework. We have a Python framework, one of our guys built, that can produce 4,000 models in 2 minutes. The asterisk is, it also creates the source files for 13,000 tables. The code is consistent, it's repeatable. We always get the same result. Idempotency is awesome. It runs locally on the workstations, no tokens. It only requires developers to develop in XML configuration files, and not thousands of them, a couple of hundred, right? This is something we developed back in our SQL days for scaling, and we migrated it to DBT when we came to DBT last year. The system even reads all those XMLs in, pulls it into memory, does sanity testing, and then it will rewrite it back out to reformat, make sure that everything's alphabetical order, which makes GitHub happy, takes out extraneous spaces, and removes developer inconsistencies. You know, inconsistencies are why we didn't like Gen AI. And volume was also the enemy of Gen AI, and I just said we've only got a couple of hundred of these XMLs. So maybe developers don't have to work in the XML directly. We set up a prompt, particularly the Python developer who wrote the framework. He set up a base prompt that can generate the XML in about a third of the time. So instead of 15 minutes to set up an XML, you can do it in about 5. There we go, there's our savings. We use Gen AI not to build models, but to build configuration files for a framework that builds models. Take advantage of the amplification and keep the job within the scope of what the Gen AI can do. So, developer ROI. Now we see 4 bars, including DBT. We're seeing pretty good gains. Tasks where we're seeing benefits more than 50%. Sounds awesome. When we look at the big picture, these are not where we're spending most of the time, right? A developer might spend 45 minutes working on an XML, right? We've now cut that down from 45 minutes to 15 minutes, good job. The next 3 days are working at the business logic. So that little slice is not moving our dial. As I said earlier, you have to be able to measure your results. We're not doing lines of code, we're using sprints and points. So we're estimating, based on the fact we have tasks, we see benefits, that we're getting about 5% developer productivity because our sprint velocities aren't changing. Our sprint story sizings aren't changing. When we look at the same task we do year over year, it's not having material impact for us yet. Now again, we have a framework that builds thousands of objects in a couple of minutes. If I didn't have that, if I didn't need that, that agent would be awesome for me. But it's not. I do have a framework. Haha. So that agent is not that useful for me. Again, know your business and be able to measure what's productive for you. So let's move on to data analysts. All right. So our data analysts have the classic thing: answer questions, and we have a very robust system. And learn about the data models while they're answering those questions. So we don't want them to just get an answer. There's plenty of ways to do that currently. We want them to also understand the logic to get that answer for the next time. We don't really want them to become dependent on the LLM. We want it to be a training tool. At least that's our goal. So we use Snowflake. We set up Cortex. We decided to build a virtual analyst. Could it answer some business questions? Yes, it could. It would give accurate answers. Could it show the sequel to the analyst? Yes, it really could. So, was it a winner? No, it was not a winner for us. But why? It sounds like it does what we need. Well, the issue is that we have a thick semantic layer that has been developed over more than a decade, right? Located in another system. And I normally don't try to fit it in one slide, and you're going to see why. Because it looks like this when you try to make it fit in one slide. We have multiple lines of business for dozens of organizations, all tied together, intermeshed, we have a lot of value in the synergies between our systems, okay? So when we try to cram that into Cortex, well, you can't. You have to pick and choose. So we pick and choose which tables we want. Except that's also not enough. We have to pick and choose time. We have to limit how much data is available. We have to compress it even smaller. We also have to move the metrics that are here over into the other logic because we can't query this. This is in MicroStrategy. MicroStrategy doesn't currently offer anything like an MCP where you could leverage that information, okay? So, welcome to parallel development. We also figured out even that wasn't enough. For Snowflake, or correction, for MicroStrategy, we use a Snowflake data model approach, not just Snowflake the platform. And Cortex really wanted you to flatten it. So we wound up with kind of the one big table approach. So that means now the SQL is not reusable outside of this particular use case that we have to maintain specially and in parallel with our MicroStrategy environment. That does not sound like it is a good return on investment. So even though it worked, it answered questions, it could develop code. It did not answer questions about the code base we wanted it to answer about the data warehouse we wanted to touch. And they have other ways to answer questions. So that one was a loser. Then let's move on and summarize. So our winners, marketing, winner, no surprise. The patron LLM, well, we predict that to win. We'll see what the judges and proctors say in the form of the market when we finally come to market. We consider the developer tools to be a win by a nose. We see gains. We're not seeing losses. So we consider it a win. And the analyst tool for us is a loser. Now, what did we learn from this? So on one hand, you want tasks that are somewhat complex. If it's simple enough, build a framework. Frameworks are faster, lower cost. They can do a ton of work for you. You need something that is complex enough that building a framework will hurt, okay? But on the other hand, if it's too big, if your workload is too large, the LLM can get confused. So you want somewhat complex, but not mind-numbingly complex, okay? You want processes that can deal with irregularity. If you have a process that currently has 2 or 3 steps with manual reviews, you can possibly use an LLM to eliminate one of the steps and then have your existing follow-on steps compensate for that. In the DBT world, it's very easy to deploy code. But if you're running a project that is then consumed by multiple downstream projects and you have to revert a hallucination in the upstream project and get 5 other teams to reprocess their data, that's kind of painful, right? You don't want to deal with that. You need tasks that occur frequently enough to maximize your return on investment, right? We're getting some benefit from our developers, but it's not moving the dials because it is not the things that they do a lot, right? They do it frequently. It happens every sprint or 2, but they're not using it every day in any way that's really making a huge impact. Other thing, look for a process that's already expensive. If you're already paying an outside vendor to do something, maybe bring it in-house through an LLM. I will point out, if you're using an LLM, you're still kind of sort of outsourcing unless you have built it and are running it on your own servers. But you're under a different contract structure. You're already allowing yourself to outsource that. Let's see. What to avoid? Obviously, scenarios where hallucinations are catastrophic. Don't expect to see any regulator documents from Churchill Downs coming from AI. Processes where the errors require significant effort to address. That's the scenario I said with the projects and the cascading. Right? Don't want to deal with that. Projects where you cannot define success in a return on investment way. Right? You can build some really awesome things in LLMs, but if you're spending 5 times as much maintaining parallel systems and supporting that, is that really the best use of your effort? Should you look at other things to provide that business value? Right? Keep in mind, it's always business value. There's value in letting your developers do experimentation for learning, for training, but always bring it back to the business value. And lastly, you have to deal with the analysis paralysis. It'll get better next release. I can do it again, right? You need to know when to cut your losses. Don't get trapped by some cost fallacy. On the other hand, you don't want to discard things, right? You need to learn from failure. You need to understand why it did not produce positive ROI. Even if it works in some cases, how could it produce positive ROI in the future? How could it work for your use case? If Snowflake Cortex quadruples the number of tokens that are available in their context window, right? I think I said that wrong, but if their context window gets 4 times bigger, maybe I can cram everything I need in. Maybe I can get enough information to make that analyst tool work, right? Or we can take what I did and find another team that's using a standalone SaaS model, right? And maybe they can just take that, they can move their stuff and just woof, push it in, and they can get value using what our approach didn't work for us, but what approach for a completely different side of your business. And then, keep this somewhere useful, because hopefully you are periodically reviewing your projects, and you want to have enough information that you can determine if it is time to revisit them. If MicroStrategy releases an MCP tool that I can take advantage of so that we can have those metrics stored in one place instead of having to recreate them in parallel, you don't want to need to have a big project to dust things off and decide it's valuable. You want to very quickly figure out, is this something we want to put effort in a near-term sprint? And I think that leaves just a few minutes for questions. What did I leave unclear? If you have a question, okay, microphone's heading your way.
Thank you. I know at the outset you said you had 5 questions that you wanted to answer about this. Did you
who, what, when, where, why?
Who, what, when, where, why? Did you end up answering all of them as a result?
Yeah, I mean, we figured out who of the users were going to get value. We figured out what value was appropriate for each of the users. Admittedly, we didn't always come up with something that provided the value to the users. We did go where they were, we went where they were going to be. The patron LLM is going to be in the Twin Spires app, which is what they're already using. The analysts already use Snowflake, so going to Cortex worked for that. The marketing folks were already using toolkits, and doing queries, and so that worked for us. Who, what, when, where, why? We already knew the why. We always wanted investment, so I think we did. Oh, and then the when, how often? And that provided some learnings, but it came back often enough in most cases. I think there was a second question someone had.
What were some of the trade-offs you had to make to choosing like the Python framework?
So the Python framework. So we came in with a lot of advantages in the sense that in our old platform, which was SQL Server, we were also using SSIS as our orchestration engine. And if you've ever tried to do Git management of that, it's painful. So we used a tool called BIML. And BIML would generate our SSIS packages programmatically. The XML files were the structure we used to do that and make sure that it was not bespoke SSIS. So when we migrated over to Snowflake, we had those XML files sitting. We were actually using them as reference documents for our migration because it listed each of the transformations, that stored procedures that were being run against each data set and the parameters that are going against it. So we could tell which objects were being recycled by which data set and what quantity to prioritize our macro conversion. So it was just kind of an intuitive step to go forward and say, well, we already have this. It delineates the columns that are used, what column names need to be remapped, data type remappings that were happening at each different source and destination. So we went with Python because, well, we had a Python developer, and Python's good in Snowflake. And it also plays nice with dbt, even though we do not actually have any Python models. All of our models are SQL models with classic Jinja. We just use the Python to produce that. That gives us some flexibility, so if we ever decide we need another platform besides Snowflake, we can do some minor modifications to our approach and theoretically have parallel environments. As far as some of the trade-offs we did, it's not as flexible as we would like at the moment. It always builds the same framework, so even if we have a process that only has one version, it builds all those stacks. Net gain, we run a couple of extra models, no big whoop-de-doo. So the costs aren't hurting us that much on that front. Do you have anything specific you were hoping for? Okay. Here she comes.
Yeah, I just wanted to know some of your thoughts on the validation strategy, like end to end. What kind of automated validation strategies you have, and is there any ROI to be gained for a data engineer to like cut down on the time on the validation that we send? Did you tinker into any of that as part of your approach here?
Yeah, so I'm not going to talk about the racing LLM side because that's a different team that worked on that. As we use things in the BI space, which is my real home, right? I have some, while I have the constraints of working with MicroStrategy where the metrics are there, I also get the benefit of using their toolkits. And they have a very extensive final tool testing where they can do comparisons between things. So in our environment, we can very quickly manifest data in two different scenarios. We can clone the projects between MicroStrategy and do the testing and look at both the SQL variations that the end platform is going to generate, because MicroStrategy is a semantic SQL generator, and look at the data values that are different and do the variations. We don't have any expectations of having the LLMs do anything live. It's all going to be things that are code committed. So it's going to be LLM generated code. But you do have to have a testing plan. We already have a toolkit that we can lean on. Now, based on what I've seen using the new Fusion comparison tool when it becomes available, good idea. Our QA team leverages a mix of the MicroStrategy tools and also the dbt audit helper tools to do a bunch of comparisons at different points. I will say test early and try to ideally find cases where you can test in one place that will serve multiple downstream consumers. I'd show you our DAG, but it's something of a nightmare. But we have lots of opportunities where we can say, if we test here, it will affect 15 downstream objects. So looking for that. Now the downside is the complexities are more. So when there are changes, you're like, well, we expect it to be better. It will fix this problem. You then have to make sure that better really is better, which gets into have you defined the test cases? Have you defined what defines better when you're addressing a bug or implementing new business logic, right? If you can't think that out in advance, you can't test it out right, or you're going to spend a lot of time going to your business team. Other questions? All right, looks like there's about 2 minutes left, so I will give you those 2 minutes back. Thank you all.